Hey everyone, I wanted to go over how to do the calculations and math portion of our microscopes lab. So we're going to be on page 3, and we're going to start off with our first question, which is right here. And our first question is, how do we calculate the diameter of the nucleus if the magnification of the image is this amount right here? So the first thing I want to make sure we understand is what each of these three variables actually means. So our first one is magnification. And magnification is pretty much the amount the image is zoomed in. So the amount the image is zoomed in. Our second variable here is the measured length of the image. And our measured length is pretty much the number that we're finding on a ruler. Sorry, not being a good example. All right, number 3 is going to be the actual length. And this is usually what we're going to be looking for. It's the size of the object in real life. So those are the 3 things we're trying to find. Usually we're going to be looking for the actual length, but in some cases they're not going to give us the magnification, and we're going to have to add in an additional step. So this first question is pretty easy. Pretty much everything is given to you that you need. So the first thing it's asking us to do is write down the magnification formula. So our magnification formula is magnification equals our measured length on the ruler. So the object that we're measuring here in this example is the diameter of the nucleus. So measured length of nucleus, I'm going to use nuke for short. And we are going to divide that by the actual length. Now, since we're trying to find the actual length, we're going to have to rearrange this formula here. So we're going to multiply this side by actual length, and we're going to divide by magnification, which is going to give us the actual length is equal to the measured length of the nuke divided by our magnification. Now we're just going to simply plug in those answers, so those variables. So we're going to do actual length is equal to our measured length of the nucleus. So for this, we're going to go up to this image here. This is our nucleus right here, and it says nucleus right there. It's kind of difficult to see. So we're going to use the ruler that is on the picture. Normally, you would be using your own ruler here, but because these pictures kind of came out different sizes for everyone, I wanted to make sure we had a uniform answer. So we could see that we are at 70 right here, and our units over here are millimeters. So we're going to do 70 millimeters for our measured length, because we're always using a ruler for measured. And our magnification is actually in our prompt. So we're going to write that down. I like to add in zeros just to make sure I'm having the correct, or I'm sorry, commas to make sure I'm having the correct amount of zeros. So when you divide that, you're going to get a very small number. It's going to be 0.000007 millimeters. Always remember your units. Now, this is a really tiny number. We want it to be a more readable term. So we are actually going to change the units. So I'm going to write this again over here. Millimeters. And I am actually going to change it to nanometers just because it's going to make the number a lot more understandable. So I'm going to take this unit conversion here. I'm going to want my units to cancel out. So I'm going to put 1 millimeter down here so that those will cancel, because when you divide millimeters by millimeters, you get nothing. And then I'm going to go ahead and put the conversion right here. Nanometers. And when you do that math, you should get 7 nanometers. And that will be your diameter of the nucleus, the actual diameter of a nucleus. Now, sometimes they aren't going to give you the magnification, and that's where things can get a little bit tricky. So I want to give you a few steps just to make sure we're all on the same page. So if they do not give you the magnification and they want you to calculate the actual size, calculate the actual size. There's a few steps that you can do. So the first thing you're going to do is you're going to figure out what the magnification is. Figure out magnification. And you're going to use the scale bar. And a ruler near the scale bar. So your scale bar is going to be a little line on this picture. Normally it will have a number above it, which is going to tell you the length of the scale bar. For whatever reason, in this example, they put it in the prompt. I think maybe it was a little bit too small to see. So normally it would look like this, right above that line. So again, this is the scale bar. And then this is the ruler that we're using to measure the scale bar. So that's going to help us find our magnification. So the second step you're going to do after you have figured out the magnification is you're going to use the magnification from step 1. And then you're going to also use the ruler next to the object to find the actual size. So we're going to use this ruler for step number 2. Okay, so let's go ahead and do this. So we're going to use the same equation for both of these steps, which is why it can get a little bit weird, but I'll walk you through it. So our magnification formula is magnification equals our measured length of whatever object we're looking at. So I'm going to put on the ruler divided by the actual length. So in this case, we're trying to find the magnification. They haven't given that to us. So before we can plug in any kind of numbers into a formula to figure out how big the cell is, we have to figure out how enlarged the image is. So the way we're going to do that is we're going to take the measured length on the ruler for the scale bar. And then we're going to use the actual length of the scale bar. So we're going to do magnification equals. We're going to take the measured length of that line. So we're going to go here to here. So here we're just measuring the scale bar to figure out how much this image is magnified. So we are going to, I'm going to say that's 10 millimeters in length when you go from here to here. So 10 millimeters, that's our measured on the scale bar. And I'm going to put on ruler just to kind of help you keep those separated. And then you're going to put the actual length. And that actual length is usually written above the line. So that's going to be our 100 micrometers. Now, when we're doing magnification, an easy way to know if you're on the right track is you should cancel out all of your units. So we are going to have to use our conversions on the previous page. Now notice I have micrometers and millimeters that I'm trying to transfer. So we are actually going to be using this one right here. We have 1 millimeter equals 1,000 micrometers. So again, we want our units to cancel. So I'm going to put 1 millimeter down here so that millimeters cancel out. And we're going to do 1,000 micrometers so that our micrometers cancel out. So you shouldn't have any units on magnification. This is going to give us a magnification of 100 times. Now that we've figured out the magnification, we have everything that we need to go in and actually figure out the size of this cell. We had to figure out how enlarged the image was in the first place, which is what we use the scale bar for. So now what we're going to do, I'm going to use a different color here, is we are going to use the formula that we used earlier, except this time we're going to use it for the cell. So actual length is going to be equal to the measured length of the cell. And I'm going to put in parentheses ruler, just to make sure we know where that number is coming from. And we're going to divide that by the magnification we just found. So magnification from earlier. So our actual length is going to be equal to, let's see, the cell starts about here, and I say it's going to end right about there. That looks about 55 millimeters. And I'm going to divide that by our magnification that we found earlier. So that's going to be 100 times. And when we divide that, we're going to get 0.55 millimeters. But when we're looking at these images, we really don't want to have decimal points. So I'm going to go ahead and convert my units. So I'm going to take 0.55 millimeters. And I'm actually going to change this over to micrometers. So 1 millimeter as 1,000 micrometers. So these will cancel, and I'll be left with micrometers, and I'll have 550 micrometers. So again, we found our magnification using the scale bar and the ruler right next to the scale bar. And then we are going to use that magnification in the formula again to measure the cell and figure out the actual length of the cell. So I'm going to let you guys do this one. I'm going to make sure you're off to a good start though. So if we look here, this is our scale bar right there. And you may not be able to see it, but it says 0.5 micrometers. So that's the actual size that you'll use for the magnification. And I'll write magnification right here just so you know. And then it looks like your millimeters for your measured is going to be 15 millimeters. That's going to be your measured. So those are what you're going to use for the magnification. And then to figure out the actual size of the cell, we're going to use this ruler right here. So it looks like it's going to be 65 millimeters for the measured in part 2. Finding actual size. So again, the green you're going to use for magnification. Second part in the red you're going to use for the actual size of that organism. And again here, just to make sure we're good, this area is what is going to be used to calculate the magnification in step 1. In step 1. So this part right here is your actual size. And it looks like 0.4 nanometers. And then your measured is going to be the ruler right up next to it. So it looks like it's going to be 20 millimeters. And then when you go into part 2, you're going to use this one. Part 2, your measured will be, looks like it's right on 50 millimeters. And you'll use the magnification you found in step 1. And then this one you should be able to do on your own. So go ahead and rewatch this video. If you need to go through the steps slower, feel free to pause as you go through. And have a good one.